All right. Let's pick up with factoring. As I said, this is liable to be a couple hours session. Okay. So, first of all, let's talk about monomials, binomials, and polynomials. Tell me what each of these is. Is that a monomial, a binomial, or a polynomial? Polynomial basically means more than bi. It could be a trinomial, it could be a quarter. Poly just means many.
Okay.
So what's 2x? Is that a monomial or a binomial?
I think it's a monomial.
Correct. What's 2x plus 1?
A binomial?
What's 2x squared plus x plus 10?
Polynomial.
Well, or a trinomial. In other words,
okay.
I can't combine any of those three terms. They're all different. So, okay, let me ask you this. What's this plus this? Is that a monomial or a binomial?
A binomial.
Well, technically I think it's a monomial because I can combine them. They are 5x squared, right? So
right.
the fact that it's two terms is not what really determines whether it's a binomial. The fact is when you combine all the like terms, what is it? And then it's a monomial. In other words, let me take the following problem. What is that? First of all, before you answer, combine all the like terms and put them in order. In other words, what's the first term I want to list?
5x.
Well,
plus
probably that one, because that's the highest degree. Okay, so I want to start my final answer with that. Now, when you combine that and that, it's true, you get that. And what happens when you combine those two? What do you get?
-9.
So now, is that a monomial, binomial, trinomial?
Trinomial.
Yeah, because there's three terms and they cannot be reduced. And multipliers don't really have any effect, but notice that that's a monomial, that's a binomial. So when I add or subtract something that can't be combined, then that's what makes it a binomial. And polynomial just means more than one term. In other words, that x plus 1 is actually also a polynomial. But so is this. In other words, that's got 4 terms in it. And I don't even know what the word is for 4 terms. But that we would call a polynomial. But this is also a polynomial. This is a polynomial. And in fact, x alone is a polynomial. So they're all polynomials, but sometimes distinguishing between monomial and binomial is key. Now, the first thing that you want to always be able to do is multiply a binomial by another binomial. So multiply those two binomials. You notice why they're both binomials.
Yeah.
Okay, now multiply them together. First term,
X to the third.
good. That handles that.
And then it would be 2x.
Always go in the same order. Do not mix it up.
Okay.
By that I mean take this first term, x, and multiply it by every other term. Complete that. In other words, the next step is to take that x and multiply it by the minus 1. So what's that equal?
X.
Minus x. You're multiplying x by minus 1. That's minus x. Now, multiply that by that. What do you get? And I need a sign. Don't just tell me a number. I need a plus or minus sign. Because once something is part of a polynomial, you have to apply the sign. Even if it's a plus, you have to write it. Unless it's the first term. Notice that this first term of x cubed, I did not have to put a plus in front of it. It's presumed. But the minus x, you can't presume a plus or a minus there. So you have to write it. Now what do you get when you multiply plus 2 by x squared?
Plus 2x squared.
Good. And now the final thing is what you're doing is every term by every term. I've never really liked the word FOIL because FOIL doesn't handle things very well as soon as you get past binomials. If you have a trinomial times a trinomial, FOIL doesn't help you at all. But what always works is multiply every term by every term. In other words, we multiplied that by that, and then we multiplied that by that, and then we multiplied that by that. Well, the only thing we didn't do is multiply that by that. So what's that last term?
Minus 2.
Now, write it in the proper order. And by that I mean write it in the highest degree on the left, next highest, next to that, and so forth. Right now it's out of order.
Okay.
How do you put it in order?
Would it be 2x squared?
Always start with that one. That's the biggest degree, right? That's the only thing that's being taken to the third power. Always where you want to start. Next thing I'm going to list is that one. Next thing I'm going to list is that one. Last thing I'm going to list is that one. So put it in order.
Okay, so x cubed plus 2x squared minus x minus 2.
Yeah, you see why that's in order?
Yeah.
Every power of x is descending. In other words, I have the highest powers of x in the front. All right. Let's get back to factoring. let me just test you on a couple. We had greatest common factor. We had difference of perfect squares. And then we have, well, I guess I would call quadratic factor. Okay? Now, let me give you an example of greatest common factor. Factor that.
X cubed would be the greatest,
Now,
right?
remember the definition of greatest common factor is something that divides evenly into all three terms. Well, that doesn't divide into that. That gives me a 3x to the minus 2. So what you need is the smallest thing. What divides into all three terms?
X.
Yeah, just x. And now what's left over? What's the first term going to be?
3.
Divide that by x. That's how you get the first term.
Oh, so 2?
What's x cubed divided by x to the 1? You got to remember these rules. What's x cubed divided by x to the 1? What do you do with the exponents?
You subtract them, so it'd be
Okay.
2.
That's x squared. If I'm subtracting the exponents, it's 3 minus 1. Understand?
Okay.
In other words, when I'm faced with that problem right there, I'm going to subtract the exponents. Well, 3 minus 1 is 2. So that's got to be x squared. And then when I check, when I remultiply those back together again, I get x cubed. And that is always the case. And that's what you should always be doing, is multiplying at every step of the way. Okay? So what's the next term?
Plus
Go ahead.
2.
Solve this problem. That's what you're doing, right?
Yeah.
Okay, what's that equal to? You got the 2 right, but now subtract the exponents.
2 is just 2x.
Exactly. And it's a plus. And again, if I multiply that times that, I get what I started with, 2x squared. Okay? So that's the way you want to do every one of these, is you just want to divide it by the greatest common factor. Okay? Now, what's the last term?
3x.
First of all, that's the last term, and we're dividing it by x.
So negative 3x.
Negative 3. When I divide negative 3x by x, that's got an exponent of 1. That's got an exponent of 1. I'm going to subtract the exponents, and I get minus 3x to the 0. That's always 1. Any number to the 0th power is 1, always. But the fact is, you should remember that x divided by x equals 1. Okay? Always. 2x divided by 2x equals 1. Anything divided by itself is 1. All right. So if I wanted to check whether I had factored this properly or not, then I'm going to multiply it back together again, right? Oh, what do I get? I get x cubed plus 2x squared minus 3x. That's the proof of the pudding. That's what I started with. So you can always tell if you factored something properly by multiplying it back together again and getting the same thing. All right, let's go on to dopes. Difference of perfect squares. Factor this for me. That's a perfect square. That's a perfect square. They're being subtracted. That's what makes it difference of perfect squares. How's it factor?
X minus 2 and x plus 2?
Yeah, always. In other words, once you figure out that term, you don't even have to give any more thinking to figure out the second term. The second term is always the conjugate. Conjugate meaning that it's the same two terms, different sign. Okay? And the way we got the first term was by taking the square root of that, which gives us that, and the square root of that, which gives us that. And the first term is always, in other words, a squared minus b squared always factors into a minus b times a plus b. This is really what you want to memorize. And you can substitute anything you want for a squared and b squared. For example, how's that factor?
2x
Yeah, figure out the first term only.
minus 3y.
Now, what's the next term? You don't even have to think about it.
2x plus 3y.
You got it. That's difference of perfect squares. There's few things easier than difference of perfect squares. Okay? Now, we'll go to a little bit harder, what I call quadratic factoring. And quadratic factoring is where you have an x squared term. You also have an x term, and you have a constant. Now, the way this was produced was by multiplying two binomials together. So the key is figuring out what those two binomials are. Okay? What were my 3 steps? What's the first step?
X plus.
Hold on. The first step is split up the x's. So I don't do one part of one side at a time. I do both parts both times. With every step, I do both parts. Remember that. In other words, when I split up the x squareds, it splits up into x times x. So that's really the first part. What's the second part?
Split up the 7x.
No. Figure out both signs. This is the hardest thing for all of my students to remember. And I'm not quite sure why. I suppose maybe nobody else teaches it this way and I'm the only one that really teaches it this way. But trust me, this is the easiest way to learn it for you at the moment. What do both signs have to be?
Plus.
Correct. So that has to be a plus. That has to be a plus. That's the second step. That's it. That's totally it. Now, the third step. Started out with the words factors of that number. Factors of 10 that do what?
That add to 10? Or add to 7?
Add to 7. Okay?
Okay, so then it would be 5 and 2.
That's right. Those are factors of 10, 5 and 2, that add to 7. Now, notice that if we started with that problem, multiplying those two binomials together, we would get x squared from that, and then we would get plus 2x, and then we would get plus 5x, and then we would get plus 10. And then we would simplify, and we would get that. In other words, whenever you factor, if you have factored correctly, when you multiply it back together again, you get what you started with. That's the most important thing to understand about factoring, is that is all you're doing is something that is a term that's very rarely used. I don't think anybody but me has ever used it, and I call it unmultiplying. That's what you're doing, is you're unmultiplying the two binomials that created that quadratic. Now let's try a little harder one. Now, I'm not going to go any higher than having a 1 in front of that term. There are two different types of factoring quadratics, and I'll just classify them as easy and difficult. Okay? The easy ones are where you have a 1 in front of that. This would be difficult. If I gave you this one, that would be a difficult quadratic because it's not a 1 in front of the x squared. Okay? But as long as it's a 1 in front of the x squared, then it's relatively easy. For example, that one. And in fact, as all you have to do is remember my 3 rules, sometimes 4. If that's a negative sign, then there's actually 4 rules. But you got to memorize them. No way around it. The key about math is being able to memorize stuff. If you can't memorize stuff, you're going to have a hard time with math. Okay? You got to be able to memorize stuff. First step.
X. Well, like separate the x's, so then it'd be x and x.
There you go. That's first step. Second step.
It would be a plus and then a minus.
And notice that it does not matter whether I write plus minus or minus plus. It's going to be the same thing in either case. What's the third step? Verbalize it for me. because that's an important part of memorizing this, is understanding it. How would you verbalize the third step?
It would be the square root of,
Use the word factors.
factor of 12.
Okay,
That subtracts to x,
not the
which would
x,
be
but the coefficient of x, which is what?
1,
Okay,
right?
so looking for factors of 12 that subtract to 1. What are those factors? What two numbers multiply to 12 and subtract to 1? Let's go through how.
4 times 3.
Yeah, let's just talk about factoring a number. Okay, always start with that. 12 times 1 are 2 factors. Cut this in half, double that. Cut this in half again, double that. There you go. That's all the factors of 12. And that's our answer, 4 and 3. Now, where's the 4 go? Where's the 3 go? The 4 go with the plus sign or the minus sign?
The plus sign.
Yeah, the larger factor, this is the fourth step, the larger factor goes with the sign of the middle term. So the 4 has to go there and the 3 has to go there. And the reason being is that when I go to check this to make sure I've got the correct, there's something that's definitely worth pointing out here. When you check to see whether you've factored something, you don't really need to check that term. You split up the x's. It's pretty easy to split up the x's. And that first term only comes from this first term times that first term. So I don't even check that one. I also don't check that term because my final rule was factors of 12, right? So I know that these two numbers multiply to give me minus 12. However, the thing that I really need to check is the middle term. It's always the middle term that's in doubt. Okay? In other words, if you really want to know whether you factored it correctly, check the middle term, and that's all you need to check is the middle term. So what I have, I had x plus 4 times x minus 3, and the middle term only comes from the insides and the outsides. Those two. That's it. That's the only two you have to check. Well, what do the inside multiply to? What's plus 4?
I'm not sure.
What's plus 4 times x?
4x.
Plus 4x. What's the outside terms multiply to?
X minus 3.
Minus 3x. There's a big difference. In other words, when I multiply x times minus 3, I get minus 3x. I do not get x minus 3. Okay?
Okay.
May seem like a trivial point, but it's gigantic. You cannot mix up multiplication and addition. It's one of the more important things in math. You got to distinguish between the two. So now, if that was the inside and that was the outside, they always get added together. Well, those add together to give you plus 1x, which is our middle term. That's what that is plus 1x. And what that tells us is we did it properly. If you do not get a middle term that's correct, then you've done it incorrectly. And you got to go back and rethink your thinking. But the key to factoring quadratics is checking your middle term. Do more. I don't think I can even give you enough practice on these. Let me make up some simple ones. First step, second step, third step.
It would be x and x,
Second step.
and then plus sign on both sides.
Okay.
And then it would be 5 on both sides.
Right. Verbalize that last step for me.
It would be 5 times 5, which equals 25, and adds to 10.
Factors of 25 that add to 10. That's what you're looking for, always. That third step is always factors of that number that either add or subtract, based on whether that's a plus or a minus, to that number. And I don't mean plus 10. I mean they just need to add to 10. Well, 5 and 5 add to 10. So that's how that factors. Now, you'll notice that they are a little tougher when there is a minus sign. In other words, when this is a minus sign, it's a 4-step problem. If it's a plus sign, it's always a 3-step problem. So that's kind of the first thing you have to figure out, is whether you're dealing with a 3-step or a 4-step. Well, this is going to be a 4-step problem. First step.
Distribute the x's, which would be x and x.
Split them up. Yes. Second step.
A minus sign.
What are they? Second step is to figure out both signs. What are both?
So it would be a plus and a minus.
Okay. Third step. Verbalize it.
Factors of 30 that subtract to 7.
Okay. What are those?
15. Wait, no.
Let's do it this way. I want you to get in the habit of doing it this way.
I was trying to do that in my head. Yeah.
Okay, well, now, can you cut 30 in half?
Yeah, it's 15 and 2. Done.
Okay. Now, can you cut 15 in half?
Yes,
No.
but with a decimal.
No, you don't. When I say can you cut it in half, I mean can you get a whole number out of it? So
No.
you can't. Can you cut it in thirds?
Yes.
What is that?
5.
And this has to be what? In other words, if I've cut that by 1/3, this has to be 3 times bigger.
6.
Okay? Now, can I cut 6 in half?
Yes. So
Which makes this what?
10.
Now, what was I looking for? I was looking for factors of 30 that subtract to the number 7. I just found them.
Okay, so then it would be x plus 10 and x minus 3.
Remember, the biggest of the two factors goes with the sign of the middle term.
Oh, okay, so then x minus 10 and then x plus 3.
There you go. And that's the way you want to do all of these, with those 4 steps. And there will never be more than 4 steps like that. As long as we're dealing with an elementary quadratic. In other words, a quadratic that has a 1 in front of that. Now, I'm just going to mention it in passing because I don't think you're going to have to do any of these on your placement test. Although you said you were going to actually be starting out in honors algebra 1, right?
Yeah.
And you're going to have to pass an exam in order to go straight to geometry.
Yes.
Which is what we're hoping for. In other words, we're hoping to save you a year of taking Algebra 1. I don't think it's necessary. I really don't. I think I can help you enough with your Algebra 1 so that you can go straight to geometry. Okay? Now, what if I were to give you a problem like this? Factor them.
X and x. And then a plus and a plus.
Hold on. A plus and a plus will not produce that minus sign. It will produce that plus sign, but it will never produce a minus sign in the middle. So instead of a plus and a plus, what must it be?
A plus and a minus?
No?
Oh no, a minus and a minus.
Minus and a minus. There you go. In other words, that, whatever number this is, when I multiply that number by that number, it's going to be plus. So just because I see a plus in front of the 9 doesn't mean that they both have to be pluses. They can both be minuses. And they are in this case. Man, I'm having a terrible time erasing this. Now, what's the third step? And this is only a 3-step problem. This is not a 4-step problem. It's only a 4-step problem when that sign is a minus in front of the 9. But since it's a plus, this is a 3-step problem. Verbalize.
So factors of 9 that add to 7.
Perfect. Are there any factors of 9 that add to 7? In other words, here's the factors of 9. 9 and 1. Notice I cannot divide 9 by 2, but I can divide it by 3. Turns out that's the only factors. 9 and 1 and 3 and 3. And neither of those factors add to 7. So this becomes a quadratic that cannot be factored easily. And there's something called the quadratic formula. I don't expect you to memorize it yet. I'm not sure you'll have to know it for this test.
Yeah, you do.
You do have to?
Yeah, I remember working with it.
Yeah, I was going to say, you've probably been exposed to it. So let's talk about it. Because this is what you have to resort to if you can't factor it. In other words, if you can't factor it in the easy way, you have to factor it this way. Now, the question is, what are A, B, and C? What's A? A is that coefficient.
So 1.
What's B?
7.
Oh, that coefficient.
-7.
Now what is C?
9.
Let's go ahead and put the plus on it, just so we don't make any mistakes. Now, the answer to this quadratic is, whoops, this right there. Okay, so let's fill it in. X equals, what's negative b? Not b, but negative.
7.
What?
7.
Plus or minus the square root. What's b squared?
14.
B squared. Not b times 2. B times b.
Oh, so 49.
Minus 4. What's a?
1.
What's c?
9.
And that's all over 2. Okay, now I'm running out of room here to write, so I'm going to write over here on the left.
Wait, but isn't it 2 times 1, but then it would just be 2?
Yes, that's why I wrote just 2.
Okay.
So, this is what x is equal to. And this is the solution to this quadratic. It's 7 plus or minus the square root. Well, 4 times 9 is 36, so 49 minus 36 is 13, all divided by 2. There's your solution right there. And what that means is x equals 7 plus root 13 divided by 2, or 7 minus root 13, all divided by 2. In other words, almost always when you have a quadratic, you have two solutions. Okay? Well, there's one solution and there's another solution. Now, we haven't been talking about solutions. Let's go back because we need to cover this also. Let's go back and make it simpler again. Now, when I say solutions, usually the way they teach math is they teach you how to factor stuff, but then they also teach you how to solve equations. And on the other side of the equation is almost always 0. Okay? Or at least that's what you want. Now, we've already learned that this factors into this, correct?
Yeah.
Well, probably the most important rule in algebra is if two things multiply together to equal 0, one of them has to be 0. You cannot find two non-zero numbers that multiply together that equal 0. They don't exist. The only way numbers, and it could be 2 or more. If I had 5 numbers multiplied together that equal 0, one of them has to be 0. Okay? Huge concept. It, in fact, is generally referred to as the fundamental rule of algebra because it is applicable in so many different cases. So the fact is, I don't know how to solve that. When I say x squared plus 7x plus 10 equals 0, I can't give you an answer. But once I've factored it, now I know that either that has to be 0 or that has to be 0. So I can go ahead and say that x plus 5 has to be 0 or x plus 2 have to be 0. Now, they don't both have to be 0, but one of them does. That's the only way two numbers multiplied together can equal 0. And this gives you a solution of x equal minus 5. This gives you a solution of x equal minus 2. Those are your two solutions to this problem. In other words, if I give it this quadratic to you as an equation equal to 0, which is where you eventually always go, in other words, learning how to factor expressions doesn't really do you any good. What does you good is when you have an equation and you're trying to solve the equation. And the only way to solve it is to be able to factor this quadratic into two linear terms. These are linear because the power of x is to the 1. This is a quadratic because the power of x is to the 2. But usually you can take a quadratic and split it up into two linear factors. And then once you've done that, you can come up with the solution. So x has to be either minus 5 or minus 2. And if I were to go back into this quadratic and substitute either of these two answers, I'm going to see that that is indeed an equation. Let's substitute minus 5. Okay, well, minus 5 squared plus 7 times minus 5 plus 10, is that equal to 0? Yeah, because that's 25. That's minus 35 plus 10, yes. So minus 5 does satisfy the equation. Well, how about minus 2? Well, minus 2 squared plus 7 times minus 2 plus 10, that's 4 minus 14 plus 10, that's also equal to 0. So in this case, both of our answers are correct. It's not always going to be the case. Sometimes you will run up against problems where you'll come up with two answers, but when you go to substitute them back in to check them, only one of them works. And the other one is called an extraneous solution. And you don't generally run across extraneous solutions at this level of algebra. When you get to higher levels, you will. When you get the logs, you will. Absolute values, you will. Even radical signs, you might. As long as you're dealing with a straight quadratic, like is what we've been dealing with for 2 days now, it's just straight quadratics, then you generally, both solutions are going to be correct. Okay? So, what time we got? We got some time. So we've covered greatest common factor, difference of perfect squares, and quadratic factoring. Okay? And those are the three most important. You want to know all three of these. Really good. Okay? You don't want to miss any problem that's like this. But what if I add something like this? How do I solve that?
You would divide by...
Remember what you want your final answer to look like. X equals some number.
Well, it would be 5, so you'd do like...
Exactly, but how do I get to that step? How do I get x squared to x? What do I have to do?
Divide by,
No, not divide.
oh, square root maybe?
There you go. Notice what happens if I were to divide. Yeah, I could divide both sides by x, and that does indeed give me an x over on the left side. The problem is I still have an x on the right side, and that's never a solution, okay? In other words, when you're solving an equation, you want it to be x all by itself, and you want it to be numbers all by itself. So that's not a good first step, is to divide by x. It doesn't solve the problem. However, taking the square root of both sides does. If I take the square root of that side and the square root of that side, the left, the square root of x squared, is x. However, what's the square root of 25?
5.
Actually plus or minus 5. And let's see why that's true. What does square root mean? Here, hold on a second. What this means is that plus 5 times plus 5 equals 25. Is that a true statement?
Yes.
It also means that minus 5 times minus 5 equals 25. Is that a true statement?
Yes.
That's why both of them are answers. And in fact, when the only thing I ever know to tell students is that whenever you are solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus. Understand?
Yeah.
Give me this answer.
X equals plus or minus 7.
Exactly. Because I had to take the square root of both sides. Now, that's different than saying, what's that answer?
7.
Exactly. That's a plus 7. That's not a plus or minus 7. If I wanted minus 7, then I would write it like this. And that would be minus 7. But if you're taking the square root of both sides of an equation, it's different. In other words, like I said, I wish there was a song. You know how they teach you the ABCs?
Yeah.
You know how they teach you well, I don't know if they teach you a song for the quadratic formula or not. I think a student told me what the song was once, and I couldn't remember it because I know the quadratic formula. I don't need a song. But believe me, I need a song still for my ABCs. If you ask me which comes first, H or J in the alphabet, you know what I would have to do?
Sing the song.
A, B, C, D, E, F, G, H, I, J, K. H comes first. That's what I would have to do. That's how geared my memory is to remembering my alphabet. I got to go back to 4th grade or 3rd grade or whenever they taught me that song. So I wish there was a song that I could teach people. But the biggest thing is whenever you're solving an equation by taking the square root of both sides. Here's an equation. I'm going to take the square root of that side. I'm going to take the square root of that side. Well, the square root of the left is x, but the square root of the right is plus or minus 7. Merely because I'm solving an equation by taking the square root of both sides. It's not that that's plus or minus 7. It's not. That's plus 7. But because I'm solving an equation, it always is plus or minus. Now, there's a slightly different way to look at that. Let's look at it just for a second. What if I did this? Instead of just taking the square root of both sides, I subtract 49 from both sides. Now I got this, right? Factor that. What is that called?
A binomial?
Well, you're right. It is a binomial, but it's a special kind of binomial. It's difference of perfect squares. So how does that factor?
X.
Always begin with the minus.
X minus and then
X minus
X
what?
plus. Oh, 7.
And what's the other part?
X plus 7.
Now solve that. So that gives me two different values for x, right? Because either that can be 0 or that can be 0. So what do I get for my answers?
-7 and plus 7?
Yeah, which is what I got when I did it properly by doing the square root of both sides. I got x equal plus or minus 7, right?
Yeah.
So by doing it in this different way, which is to subtract 49 from both sides and then factor it as difference of perfect squares, I don't even have to worry about making that mistake. And I guarantee you that 90% of my students make this mistake. If I ask them to solve that equation, 95% of them tell me x equals 7. That's not the answer. It's not x equals 7. It's x equal plus 7 or x equal minus 7. And if you do it the other way, you automatically get both correct answers without possibility of a mistake. So this is kind of the fourth way of solving quadratic equations. Okay? In other words, you have different kinds of quadratic equations. What if I gave you this? Solve that.
I would add 1, so it would be x squared equals 9. And then do the square root. Then it would be x equals plus or minus 3.
There you go. Good. All right. I think we've done enough factoring that you should be comfortable with factoring. And you should be able to answer most any factoring problem they give you. Okay? And that puts us down to this part right here. Factoring polynomials. Solving polynomials. We've done the first 4 parts of that. Solving an equation by factoring, we've done that. Factoring polynomials completely. We've pretty much done that. We can make it a little harder and finish doing that. Characteristics of quadratic functions. Well, the only characteristic you really need to know is that there's an x squared term in there. Not x cubed, not x to the 1/2, not x, but an x squared. We have not talked about graphing quadratic functions. That's where we'll pick up next time. Those are parabolas. That's how you graph. All quadratics graph as a parabola. You know what I mean by a parabola?
I've heard it, but I forgot what it means.
That's what a parabola looks like. In other words, if I'm graphing a parabola, it's going to look like either that or sometimes it'll point down. But it's one of these two types of graphs. It either points up or down. And all quadratics graph as parabolas. All right. We'll pick up from there next time, Phoebe.
Sounds good.
Have a good rest of your weekend, and I'll talk to you next time.
Yep. See ya.